Welcome back to another episode of Freeform AI. My name is Michael and I do data engineering and machine learning at Databricks. I'm joined by my co-host. His name is
Ben Wilson. I design tables and schemas at Databricks.
damn right. And that's the topic we're going to be chatting about today. So Ben and I recently joined the same team and we are now going to be working on the same work stream, which is fucking awesome. I'm very excited. And I will hopefully be able to stop working on the current work stream, which is not as fucking awesome. But today we're going to be walking you through how we're approaching doing a research spike for the current work stream of interest. Research spikes are often a very different style of work than taking a known and proven prototype into production. And so we're going to be talking about how to fail fast, how to focus on creating the MVP and the most valuable aspects of a solution in the least amount of time possible. We're also going to discuss what should be thrown away, what should be permanent, and what code is used to actually inform decision. So this hopefully will be a real life case study that you can apply to your own work. And for us, it is a real life case study. So we're getting a free 1 hour just chat about it session. And we'll discuss sort of the meta principles around how these should be run. Before we do that, Ben, can you sort of give a high level of what we're actually building?
I actually have no idea, man. I was hoping you were going to tell me. No. So we got this system that interfaces with all these cool LLMs. We built a bunch of agents and a bunch of functionality that helps sales folks that deal with Databricks customers, that like they're the primary point of contact when a customer's like, what are you guys releasing next quarter that we can use? And I have a problem with setting this work stream up, or I need some help in thinking through how we're going to ingest 48 terabyte data set over the next month or something, or build some application. So these people are overworked, overloaded, just having to context switch all the time. And when you have to keep all of that in your brain pan, I have no idea how they do it. Where it's like, hang on, you got 10 accounts that you got to talk to in a week, and you have to remember or keep notes on everything that's going on with these, and also remember the last 4 years of history of this account. I don't know. I don't think anybody does that exceptionally well because our brains are not designed to do that. So what we're looking at is, how do we help them with that? How do we help them with an absolute fire hose of data coming in at them? And that data can come in the form of customer emails, customer docs that they want to share, slides that come in, like here's our architecture slides of what we're thinking of, project plans. It can be meeting notes that are like human transcribed. It can be Gen AI transcribed meeting notes. It can be markdown files that people are just keeping on their local computer.
And also all the tabular stuff like Salesforce data, right?
Yeah, like your mileage may vary on how accurate a lot of that stuff is, but there's a lot of information in there. Asking somebody to do that for one account is rough enough. Asking them to do that for 10 is just impossible. So you and I are tasked with, can we build a memory storage system for context of a given account that the people involved in that account can freely upload whatever they want, and it be kind of like a smart repository of the state of that account for different topics.
Precisely. And why this is so exciting, at least to me, is we're at this Gen AI transition where, all right, LLMs and AI is going to be super helpful. But the two frontiers that I have personally observed are one, asset and world interaction. So if I want to create a Google Doc, does it format it properly? Does it look like a human wrote it? Is there a freaking M dash somewhere in there? Can it respond to comments? That type of stuff. Sort of the MCP style, API call style, hands, arms, legs of the LLM. The other piece that has seemed to be a frontier is the context. So I've worked at Databricks for whatever number of years. I know how stuff works generally. And in my brain, there are processes that I follow that have helped me. I also know where to find stuff. But an LLM that is not trained on our internal context might not know all of these processes. So we're looking to solve that issue, that second issue. And historically, it's been like, all right, we'll RAG it. All right, we'll MCP it and create all that context just in time. all right, we'll do all these sort of weird ways to augment context to give a base brain, the like core LLM, knowledge about our use case. Fine tuning was really popular a few years ago. What we're looking to do is create a data structure that you can query just in time, so in real time with very low latency, that will dynamically assemble the perfect amount of context, no more, no less. And that context has to be correct and up to date. So this is one of those holy grail industry problems, and it's really exciting to be back on the cutting edge with some of this stuff.
Yeah, and this is a problem. What we're digging ourselves into right now is something that's being actively worked on in industry, period. There's no real solution that's out there for it. There's stuff that gets approximate locally to somebody's computer where you can point a coding assistant or a workspace buddy that'll go and search through your files and folders and summarize stuff and then provide basically a summarization, knowledge store that it can then use for contextual references when you ask it to go and do something. What we're building is how do you do that, but make it shareable and put it into a place where everybody can use it. And it's the same architecture for everybody, not localized little islands of isolated functionality. So that if you and I were both working on the same account and we were both coming in as like professional services, we don't have to go and ask the account executive and the solutions architect to be like, guys, can you give us a rundown of the last like 3 years in this 15-minute call real quick? Or have them do a dump of like, we're going to share our account's Google Drive folder with you. And you open that thing up and you're like, bro, there's 800 documents in here. This is going to take me 2 weeks to read all this stuff. Not happening. Where's the TLDR here? Just give me the facts. That I can
Exactly.
read in like 10 minutes. And
Yep.
that's what you and I are building.
Yes.
So that humans can use it as well as LLMs or agents.
Cool. So we have about 2 weeks to prototype something. Before we talk about how we're actually going to be doing that and what potentially we're going to be doing, you mentioned something that kind of makes me sad. It also makes me excited. This thing that you mentioned is that everybody is working on this solution. It's a very important knowledge graphs concept where real-time context generation with a low latency lookup and ensuring high quality. This is a startup, right? This is a very well-funded company that if we crack this, it'd be very valuable if we can make it generalizable. Do you think that by the time we roll this out, industry will have created the solution in a better and more robust way, and we're just wasting our time?
Irrelevant to me. Like, I don't care. I'm all for people building tooling that, like, you showed me a link this morning. You're like, check it out. OpenAI has like the red teaming agent for Claude Code. When did I tell you about when I built my own?
Ago, I guess.
Yeah, it was like 2 months ago. And I was like, this thing seems to be working pretty well. And then, yeah, they just released it. Kudos. If it's better than mine, I'll start using it. Sweet. I'll just delete my code. No big deal. I never get attached to stuff like that. Like, oh, I want to be the first. Because you and I are not looking for Y Combinator funding. We don't care. We're not in that game. We're here to provide value for our users and make this project like actually solve a problem for people. If a year from now, OpenAI or Anthropic come out and they're like, we have a tool that does exactly this, just install this system, you and I will be the first ones to be like, let's get it up and running. And then we'll do a bake off, see if it's better than ours. And if it is, we'll port our code over. No big deal.
I don't know, man. I like my things that I build. I still sometimes struggle to shut down production systems that I've created. I have some affinity to it. What's your psychology around? It's just about solving the problem. It's not.
It's exactly that. Like, I don't do what I do for, like, the artifact that comes out of anything that I work on is not the actual bit of software that I do. It's twofold. One is, did I solve a problem in a way that delights people? If so, win. Like, great. Like, people are using this thing. They find value in it. They love it. Like, that makes me feel good. And the converse of that, if it doesn't solve the problem, then I'm like, I must fix this now. and respond to all the user complaints. The second thing, the true artifact that comes out of it, me 5 years ago, the artifact would have been, what did I learn in doing this? And that's all I really cared about. Me today, it's what have I learned in doing this that I can then translate into teaching somebody else? And that's it. So did I learn something clever that was like, I had no idea that I could do this thing or that software was capable of doing this in a way that simplified it and made it accessible to like junior people? Then how do I teach that to them? Those are my artifacts. That's all I really care about. At a certain point, it's just like, dude, there's so much code. Like, if you've been doing it for long enough and like really pumping out code for a long time across many, many different work streams, you don't even remember what the heck you built 6 months ago. It's your brain no longer has the capability of even emotionally attaching itself to that. It's just too much volume. So it just becomes like, whatever, just trying to solve problems here. But what retains in that mode is what you've learned. What is your new state of wisdom?
Sure. All right. Final psychology question before we get into it. I think what the thing that bothers me the most is the fact that if I had exhibited patience and just simply bought the solution or just waited a few months until the solution was out, I could have done other stuff. What do you think
Sure.
about that?
Yeah, totally. That's part of like the research layer, and like, what is the temporal influence on what you're working on? Is this something that if we don't solve this, like, can we wait 6 months? And if the answer is no, roll our sleeves up, man. Let's build something. If something better comes out later on, sweet, let's use it. It's all about like the use case, right? The end user. And if what we're proposing isn't so critical that it needs to get done now, maybe work on something else. If it's like, this isn't that important, we can wait a little bit, no big deal. But with the project that we're working on right now, we are at the inflection point. Like, the baseline has been built as of now, and this is the limiting factor on the next epoch of evolution of this system.
That
So we
makes
have to
sense.
build it.
Okay. I like that one. That one was satisfying. Cool. So, what the hell are we going to do the next 2 weeks?
We're definitely not going to be building a graph rag solution on New York that. So what people on the team have done is we did a PRD, like product requirements doc, of like, what the heck is this part of the product that we're building? And that's our reference for an initial design happened last week, where we're kind of blocking out milestones of what is the end state that this product could be. And that's just theory. We have no idea what the shape of it's going to be, because nobody's ever really done this before at the scale that we're doing it. We have to bite off chunks of the elephant first in order to learn. So phase one that you and I are working on this sprint and maybe next sprint is, what is this, like, the dumb, simplest thing that we can do just to learn how dumb we are and how we can fix it.
Define the type of dumb we are that we're looking to find.
Ignorance, like the true dumb. Like, we just don't know if this even works. We have theories, but in order to test this out, we have to build something.
So, it sounds like we're starting from a set of requirements that have been defined somewhat prior, and we can modify or mutate them a bit. But where did these requirements come from, and how should they be generated?
I mean, these are directly coming from users who are like, hey, I have the following pain points of, like, my account status is in 17 different places right now. I can't keep it all in my head. I keep on not remembering things, or when I have a conversation with with somebody, we have to reiterate stuff. I can't go on vacation at a certain time because I can't pass context off to this other person. It's like real world pain points of too much information, and there's no efficient way of handing that off, which then morphed into, hey, it would be really nice if I asked a question of some of the agents in this product that you guys built, and it knew my account and it could answer questions with that context. And that's what opened this up to, okay, we need some sort of semantic memory system here. And how the hell do we build that?
Okay. So it sounds like listen to users, try to root cause their pain points. One common edge case when we're thinking about these types of systems is what happens if you don't have users yet?
Then you make an educated guess, and you have to start as simple as possible, knowing that whatever you build, you might throw all of it away. So go as light. Sometimes like if if you got a deadline of like I need to collect feedback, I know this is shit, but I just need to know like what direction to fix. I don't know like how people are going to take this yet. Release the shit and make sure that you release it to a beta group who understand that this is half baked. We just want you to play around with it and tell us what you hate and what you love. And you collect all that and, you know, really think through common themes of what people are complaining about, and then looking at the product again yourself through that lens and being like, yeah, that sucks. Okay, I'm going to draft a mental plan, and then I'm going to put it down on a document. But like, what do I need to fix in order? And then if I were to fix all of these at the same time, what are constraints that are shared between these to influence my architecture so that I'm not like playing whack-a-mole architecture wise, like fix this one thing and then I'm moving on to this next thing. I'm like, oh, what I just built, oh, I got to change that now too to support this. So that's why you go through that kind of, it seems non-intuitive and kind of painful, but that is like the product engineering mindset. Like release an MVP that's kind of half baked, just to, and it has to work. It can't be like it's an exception factory. It's got to be like it does its thing from end to end in a stable, predictable way, but the output might not be that great. But at least you start collecting feedback and identify common patterns. They're like, all right, we know where we can go here from here to make this better.
Yeah. So it sounds like we're being very agile in this development style where we build something, get feedback, and just iterate as quickly as possible. Um, I have been conceptually drawn to the waterfall approach. I know it is like the incorrect one usually, but it's really fun to like master plan something and then be like, I know everything, and then I build it, and you're like, here you go, this is what you want, right? And it usually, at least sometimes, is off the mark. How do you think about shipping fast prototypes? How do you think about creating a so to refine the question a bit, basically we're using these to gather more data. We say, all right, does this solution meet this need? If yes, continue down path X. If no, pivot. And obviously that solution space is very complex. How do you think about creating accurate steps so that you can get really, really good signal on the question you're trying to ask?
That's where experience comes in. I think everybody has to start from, or everybody does start when you're like assigned a task, some massive project that you're going to be working on. Everybody wants to do the waterfall. Like it's like human nature. Like, why would I want to intentionally ship like bullshit out to a user? It doesn't make much sense when you really think about it from the lens of like this artifact that is coming out into the world is an extension of me, of like my skill. So that's kind of like ego driven development, and it's natural. It's like how people build stuff. But what you can find after doing that a couple of times is what you said, like a lot of times, or maybe some of the time, it's off the mark. If it's just you doing it and there's no real pressure and there's not like a ton of users, it's not that important. No big deal. Go back, fix it, move on. But when you have a team around you and a product around you, and the the progress is kind of destructive in nature if you hold off and wait to build the cathedral when you should have built the farmhouse at first, you're wasting everybody's time. Most importantly, your own, because you sunk all that time into making this like amazing thing in your mind at least, and then users are like, yeah, it doesn't meet the requirement that we actually really need though. We need it to do this thing. And then you go and look at the cathedral and you're like, oh no, those buttresses that are up above our head holding the roof on, they need to like completely change. And then you start looking at it and you're like, well, for the buttresses we need to build, the foundation needs to be completely changed. So now you're looking at, I built this cathedral out of the wrong material, and you have to tear the whole thing down and rebuild it from scratch. So you could waste months of time by doing that. Whereas if you started with a little shitty thatch roofed farmhouse, whatever, man, it's like a sprint to build that thing. And if the roof doesn't support it, you're like, well, if the walls don't support the roof, you're like, okay, let's go build a stronger farmhouse on a plot adjacent to this. Takes a couple of weeks. You built a foundation that's a lot better. Maybe the foundation is over-engineered for what you need to do, but you'll know where you need to directionally go by doing that. And then 2-3 months later, you're actually erecting the cathedral that you originally wanted to build, but it's actually what people want to go and worship in. And that's why like the agile methodology works.
Yeah, I remember when working on ML Flow, I think Corey mentioned to me, who's one of the tech lead style contributors, he said that basically every single line of code in ML Flow gets deleted or rewritten within a few years. And it's just like a living, breathing instance where what you write is probably not going to be permanent. And instead, you're solving a current issue for users and also gathering data on future direction for the repository. So the repository or the feature is actually living and breathing. And just like human bodies, like we shed skin, we shed hair, everything else, it regenerates. It's actually kind of a beautiful analogy, but it's also like maybe tough if you wrap some of your self-worth up in your tangible accomplishments in life, not speaking for myself at all. So that's just been like an interesting analogy that I've leveraged, is it's just like a living thing where you want to fire and forget, but also you got to remember that it needs maintenance, it needs care, and also the world outside is changing, so sometimes your system has to change as well to meet those needs.
Beautifully put, man. Like that is the nature of software. Every so often you get that extreme outlier case where you go into a code base that you might have contributed to 10 years ago and you go and find like 5 or 6 modules and you're like, dude, nobody's touched this in like 10 years. What the hell? And it just kind of blows your mind because that's so out of the ordinary. Like maybe you built something that was ideal and like accidentally perfect that people are like, yeah, we never have to touch this. Like, why would we? It's not broken. Or it's, yeah, nobody really uses that anymore. So it's kind of abandonware. It's marked for deletion. Fine. Cool. But sometimes you do end up making something that's like, how is this even possible?
Yeah.
Because the norm is refactoring, like expanding functionality. And sometimes you don't want to do the entire architectural foundation of a project to be rewritten because you all of a sudden realize that like you have messed up and gotten yourself into a situation that just doesn't support what you're trying to do anymore. You want to be able to say, okay, we can replace pillars and like individual foundation footings piecemeal. And over time, I don't even know if the cathedral analogy is even applicable here. Think of a classic car, right? Classic car, like 57 Chevy. You see one driving just cherry down the road in a town or a city. And you're like, man, somebody really took care of that thing. Like, wonder how that was stored. Go and talk to that person. Be like, where was this? Was this stored in like a museum or something? Like, how many miles are on this thing? And they'll be like, on which engine? This is the third engine that has been in this thing. And you're like, hang on. Well, what about the body panels? No corrosion ever? And like, nothing on this car is original. Like, to make it drivable and like performant, it's just been changed out as parts fail. That's what software's like.
Yeah, I think that's actually a beautiful segue. So we've identified sort of step one of identify the problem, talk to users, or make an educated guess. But step two is, all right, we generally know the next set of success criteria that we're looking to meet. So how do we work towards that in a scalable way? I could just say, hey, Claude Code, fix it. Auto accept all edits, and it'll make something that, I don't know, it'll produce something. But probability is very high that it will not scale whatsoever, or it will not meet our subsequent jump. And I think you mentioned experience is really important here, but when you're building these high signal prototypes, how do you think about what should be a constant design tenet for the foreseeable future and what should just be good enough and hack it?
Nothing. I mean, for different milestone phases, the way I see it is when you distill your problem down to like engines, you're like, hey, I know that this thing is going to need like a jet motor in order to like function correctly. But I'm going to start with the lawnmower engine because I know how those work really well and they're super fast to build and we can change this thing out without disrupting a ton of stuff. So we start with that. We build a go-kart, not an F1 car. The tendency a lot of people have is when they see the PRD, the product requirements of what the end state should look like, is they're like, well, I I see the F1 in front of me. Like, let's just build the F1. But if you do that, you're putting way too much faith on the product requirements being aligned to reality. You just don't know at first. You can assume and be like, I think this, yeah, this makes sense. You can get some serious confirmation bias going of like, yeah, this is the direction we need to go. But if you're approaching it from the let's start small and incrementally build it up, you can start learning that like, okay, the users don't need a car that goes fast. They need a boat because they're traveling across water most of the time. Maybe we shouldn't have built an F1. Those last I checked, they don't float very well. They go fast, but not fast enough to like drive on water. So taking the incremental approach, you can identify certain invariants about a system that you can be pretty comfortable with. Like, we're going to build this and it'll work whether we're building a lawnmower or an F1 car or an attack fighter jet or a naval warship. All of these different vehicles all have the same needs. They need a fuel system. So the fuel system, it needs to support some sort of like transmission of fluid that is combustible in one way, like from one system to another. So we can build that and we can build that and we probably won't have to modify it too much. So in software, that's stuff like, okay, our REST API interfaces. The
I was
native
about to
interface,
say,
the
can you
schema might change. We might modify that as we go along. But stuff like the routers, the handlers, like how are we passing data into and out of our system? That's not really going to change that much. Or when you start talking about things like telemetry, user uses this API, we need to record that to be like, are people actually hitting this API? Are the systems that are supposed to be calling this hitting it when they're supposed to be? Okay, that's not going to change that much. Or the thing that we were talking about before we started recording, which is like back pressure systems. If we create this system and don't provide some means of queuing things up, we're just going to overwhelm LLM APIs because we don't know if it's like one user doing like we're doing, testing things out one by one. You could have a user that's like, well, I'm going to ingest 1,000 documents right now. And they just hit go. And all of a sudden you get 1,000 LLM requests in a second. Like 950 of those are going to 429 on you. So what do we do? Do we put exponential back off in the retries? How long do we have to do that? Do we just retry for like 4 hours? That looks stupid in code. Like, we now create like a huge complexity in control flow logic to just make this system work. Or we can say, all right, let's just build a queuing system. If we don't have slots available to run, it just gets queued. And when a slot is available for it to execute this task, then it'll run. So now we build a queue system, and we could change everything else about the project, but that'll stay the same because it's an invariant.
Yeah, that makes sense. So when we're thinking about the different potential sets of solutions, we have a constrained space where you probably need a database. You probably need a lookup mechanism. You probably need a way to update the database. And then you also have SLAs like lookup latency and update latency and things like that. So, all right, we're in the database world. And then further and further, we can develop less and less confident assumptions about what our requirement spec looks like, and then build a small prototype that actually tests a lot of those not so sure invariants and get direction.
Yeah. And we get our user feedback and then we say, okay, we thought we had all like these 20 things to do for phase 2, but we just found that 10 of those are irrelevant now, but we got 20 additional ones. So now we have 30 things we have to tackle, and we can grow on top of phase 1. We know some of phase 1, yeah, we'll just delete that. Or it's like, we thought our pipeline was going to look like this, but now we know we need 2 additional stages and one of the existing ones is garbage. So let's just change the code and we'll adapt.
Can you walk the listeners through the conversation we just had about like RAG graph systems? So specifically, to me, this is a very logical application for graph RAG. You have nodes, you have edges, you sort of want it to self-organize. You want to have sequential lookups where you start at a location and then do a couple nodes deep to get relevant context, but not go 7 nodes deep so you get too much context and the context blows up and gets oversized. But you astutely pointed out that neither of us potentially are experts in graph databases, but both of us know relational databases pretty well. So can you explain the thought process around steering things into your wheelhouse when you're trying to build it, when you're in the build it phase, versus saying, this could be an F1, this could be a small prototype. I'm not quite sure. I haven't actually used this tool before, but at surface level, it looks really good. So how do you balance that trade-off?
So I think I gave you the wrong impression about not being familiar with graph databases because I have built them before. I got burned the first couple times I did it because I didn't know what the data had in it. And I just started dumping it in there. And then I was like, why does this suck so bad? Like it's pulling irrelevant content. It's finding associations that I didn't foresee. So then I went into search lookup functionality, internal like logic. I'm like, okay, I'm going to put my own search algorithm in here. And it was just like trying to navigate a dark forest with no map and no compass. Everything kind of looks the same. You don't really know like where to go or how to get out of it. You're just mired in complexity and like, obtuseness. Like it didn't work out well until I stepped back and I said, all right, I clearly need to drop all like the entire instance here and rebuild this from scratch, but why was it failing? And I did some reading and people are like, you need to know the data that's going in there and it needs to be kind of like strongly typed. You need to have metadata that the system can actually leverage, and it has to be consistent. It has to be some sort of hierarchy, like defined types. And I quickly realized like, yeah, I haven't even really looked at the data that much, except for surface level, like a couple of samples. Then I started doing statistical analysis on it. And I'm like, yeah, this is an absolute mess. No wonder this system is losing its mind. So then went back and was like, all right, how do I map all of this? 4 months later, I had something that worked. It's just loads and loads of work. LLMs are going to help us do this because they're really good at classification, provided strong constraints on how they're going to do it. But years ago when I was doing it, yeah, I was clueless about it. So I learned from that, like careful of new technology if you haven't really used it before for selection in a major project. So
Okay.
that's why the simple thing that we can do, we can get 2 birds with 1 stone here, where we can get a fast prototype out based on probably not the right architecture. Maybe it is. Maybe it'll work out. And like this first pass that we do, things actually work really well. And we just saved ourselves months of like headache of trying to like put an advanced system together. And the system will still be advanced, but it's not going to be like, okay, we really got to understand stuff here.
Mm-hmm.
And the other benefit that we're going to have is we're going to have an ontological mapping of what the data is by process of forcing it into a relational database. We need columns, right? We need something that we can force our REST API when a query is issued, we need to return relevant data. So we're coercing the data structure in pre-processing before it goes into the lookup table into a format that'll also work for graph. except it's just way simpler because we can, how many times have you and I created like databases and tables and schemas? Like it's so second nature and it's so fast, and we can iterate. We needed like 2 more columns here, and that one column, that's useless. Let's drop that until we have something that's a data model that's refined enough that meets the basic needs of the first MVP.
Yeah. And that makes perfect sense. And one other thing that I've found really, really cool when building these prototypes is, and I'm also always amazed by people who have really strong fundamentals in something and can make like linear regression predict the stock market perfectly, which is, of course, not ever happened. But in this instance, we can actually create a lot of graph functionality with relational tables. It's a little hacky, but if you just have sequential calls, and metadata, that's super doable. So steering it into our wheelhouse, also the Databricks wheelhouse, we have really good relational database offerings, and we don't really have a graph database offering, although you can create in-memory ones and such. This will be a lot easier to prototype and a lot simpler to build. Yeah, when thinking about this build it phase, also think about your tech stack and your skills, because for someone it might be like, all right, this is super doable, but for others, you probably want to stick to a different approach. So I'm curious, Ben, I feel like we've actually sort of summarized this pretty well, but do you have any miscellaneous tips or tricks on doing research spikes? I'll start off with one, which is time box it. You can go down crazy rabbit holes, and for me, they're the fun aspect of the job of like seeing if I can meet the cutting edge solution, and that's very dangerous. You do have to do other stuff that provides value to your team. What else do you have?
My big stuff that I think about when working on greenfield projects is, I guess it's like calluses from doing product engineering for so many years, of identify and prep for the unsexy work that nobody thinks about. When everybody's thinking about a project like this, everybody's like, oh, we're basically doing like neural semantics storage. This is like emulating like how the human mind works with like summarization, distillation of facts. Yeah, I get excited about that. It's kind of cool to think about it and think through it. But I'll let my mind wander on that, usually when I'm like working out or something. Like got music blasting down in the garage, and that's when my mind is free to like just play jazz and like, think about crazy shit that I wonder what Michael and I are going to build on this thing. This is going to be cool. But when I'm sitting down in front of my computer, I'm like, all right, what are the invariants that I need here so that this is not insanely painful for us? Like doing, like actually building this. Okay, I know I need, like, what are the 6 REST APIs we need to create for the app in order to make this not a complete shit show when we implement it? And stuff like, well, we need something that's going to write data to these different tables. So those are REST endpoints we need to create. We need a listing API for like topics to return, and then we need give me the data APIs. We don't have to have all of them built out at first, but we definitely need like a create source API. So if raw document comes in, we safe store that in UC volumes, and then we actually create as part of that request. There's another path in there that the handler is going to write to Lakebase, to the Postgres database. And be like, here's the location of the file in UC volumes that is confirmed to be written. And here's a quick summary of it. And here's some tags and facts that it extracted from it. We also need that list sources. So it's like, for this particular topic, what are all the sources in UC volumes? I'm not going in the UI and looking for that stuff. That's going to be an absolute jungle of insanity. So how do we have that API for the UI to use? Like, for this particular fact, here are the sources that back it up, just as reference. And then being able to get a summary of the account. So I'm like, hey, account A, give me all the facts that are like all the factual summaries for each of the topics. Display that in the UI. Users are going to need that so that they can just feel comfortable about using this thing. They're like, yeah, it totally got like the summarization of that. It's awesome. I trust this. Mileage may vary about how well we pipe that into everything else in there, but at least you give the users comfort in that, like, this is not garbage. And then topic summaries, you need a lister for that. You need a get topic summary API that's like for customer A with topic UC like volumes. Are there any facts associated with that? All right, give me the summary of that. This customer is evaluating this right now, and they might move all like a lot of their data to that. Sure. And then a tombstone claim. So users need to be able to say, like, this is no longer factually accurate. So we need to be able to flag and tag facts that are like no longer relevant. And then basically some API that allows for re-ingest. How do I heal this data?
Yeah, I think I'm just going to make a graph database. All that sounded pretty boring.
But those invariants, even with a graph database in the back end, we still need all those APIs. You still got to be able to tag on a graph database. That node is garbage. That's a Tombstone API. To be able to recompute the graph connections, those edges, that's a re-ingest trigger API. What the API does in the back end, we can change that to do whatever. It can talk to Postgres right now. Later on, it can talk to Neo. We can change that logic. But that API it needs to be there, or else the UI doesn't function. So that's where my mind goes with these things. I'm like, let's define those and let's build those. And once they're built, we no longer have to worry about them. We can do the fun stuff.
Yeah. No, super well said. I'll prepare to start building boring APIs. All right. I think this is pretty wrapped. Any other comments before I summarize? Cool. So today we talked about a active research spike that both Ben and I are working on. We will generally subscribe to the following steps of iteration. First, identify the problem. You want to listen to users or make educated guesses. Second, you design a step where invariants are validated and leveraged. So if they become invalidated via this step, all right, we should change some initial assumptions. If not, we can double down on those invariants and we have further data that they truly are invariants. Next, build it. Just do it fast, but make it generally maintainable, hopefully, probably. But again, the point is getting signal on these invariants. And then finally, get feedback. See if users like it. See if you did not understand the critical user journeys initially. Then some miscellaneous tips. Be ready for the unsexy work, as Ben just mentioned. Also, you want a time box. Make sure that you have a finite amount of time to build a prototype so you don't have scope creep and just go down rabbit holes without providing value to your team. Also, be aware of human psychology around waterfall. It can be really fun to have more ego-driven development and say, I know you need a Formula One car and build it, but then maybe the user actually needed a boat. And then finally, let urgency drive whether you build now or you wait for a solution to come out in industry. I think this is super relevant for the pace that Gen AI is providing for the tech industry. Anything else?
Sums it up.
Cool. Until next time, it's been Michael Burke and my co-host,
Ben Wilson.
and have a good day, everyone.
We'll catch you next time.